The number one ingredient for a severe thunderstorm, let alone any thunderstorm or precipitation, is water vapor, moisture in the air. A severe thunderstorm can use 1.1 billion pounds of water vapor. Now, in the plains, 90% of the water vapor comes from the Gulf of Mexico. Evaporation over the Gulf of Mexico produces the water vapor. This water vapor gets transported north. If there is enough water vapor along with other ingredients, such as fronts and wind shear, you can get severe thunderstorms. How do we know if there's enough water vapor in the air to create a severe thunderstorm? We use the dew point temperature. The definition of a dew point from the National Weather Service is this. The dew point is a temperature the air needs to be cooled to at constant pressure in order to achieve a relative humidity of 100%. At this point, the air cannot hold more water in the gas form. If the air were to be cooled even more, water vapor would have to come out of the atmosphere in the liquid form. The dew point temperature usually needs to be in the 50s and low 60s at least for severe weather. So the dew point measures the amount of moisture in the air. For example, if the temperature is 67 and the dew point is 43, the humidity is 42%. This means the air has to cool to 43 for the air to be saturated and dew to form. At night, given the right conditions of a clear sky and light wind, and the temperature cools to 43, the humidity rises to 100% and the moisture condenses out to form dew. Now, we can do a simple experiment to demonstrate the dew point.
But this is a readout of our outdoor weather station. It says right now outside it's 58.6 degrees, the relative humidity is 69%, and the dew point is 48, meaning the air mass outside has to cool to 48 degrees for dew to form, or for there to be 100% humidity. Now, let's go outside and prove it. We have a thermometer, a glass of water here, a vase of water, and ice. So the water temperature at this moment, it's tap water, it's reading at about 74 degrees. So if we want dew to form on the outside here, that means it would reach the dew point. We have to cool this water to 48 degrees, and the way to do that is with ice. So let's give this a try. So we're going to put ice in here. Actually, now I can see it. There's actually dew here on the glass. It's forming right at 48 degrees. How about that? So dew formed on the outside of the glass at 48 degrees. What we've done is take the outside air and cool it to 48 degrees right near the glass with the ice. So the humidity's got to 100%, and then it cooled it even more, and it started to condense out. The moisture condensed out, and there we are with dew. We have reached the dew point. The humidity is 100% right next to this glass.